Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to go over some example problems of doing unit conversions, unit calculations. So let's get into this. So whenever you're given a problem, like a word problem, and it's got all these numbers and they want you to figure out how much of something comes from another thing, or how to convert the amount of a given substance to the amount of another substance, or even that substance to a different unit. The thing you gotta pay attention to is, what are they giving you, and where do you begin, where do you end, right? So those are the things that I want you to get out of how to do these problems. If you can remember that strategy, then really you could do any problem. So in this problem here, or in any problem, you want to pull out anything that is a relationship that you can use as a conversion factor. That would include things like percentages, percent by mass, percent by volume. That could be density, it could be molar mass, it could be anything that has one thing related to another thing. So you're looking for that. Anytime they give you that, you're going to pull that out of the problem, and then you're going to set that aside, and you're going to look to use that as a conversion factor. Second thing is, you want to figure out where to begin and where to end. And look for the question. If there's a question, 99% of the time, your ending is in the question. I would say almost 100% of the time, at the beginning of the question is going to be the end of your problem. Okay? And then the beginning of your problem is going to be somewhere else. Like 99% of the time, it's in the question. But if it's not in the question, it's somewhere in the problem. And you're looking for that one amount of something that they just kind of give you to start with. It's not related to anything, it's just there, right? Okay, so let's apply this to these problems here. So, problem number one, the mass of the ocean they're giving me is 1.8 times 10 to the 21 kilograms. Okay, so that's a piece of information they're giving me. If the ocean contains 0.014%, there's a percentage. That's going to be a conversion factor because it's relating percent by mass. It's the overall mass of the ocean related to the mass of hydrogen carbonate, that ions that are in the ocean. So out of 100 kilograms of ocean, because that's what a percent means, right? Percent means out of 100. So if 0.014% by mass of your ocean is hydrogen carbonate ions, that means if I have 100 grams or 100 kilograms or 100 tons of ocean water, then that means that 0.014 grams or kilograms or tons is going to be your hydrogen carbonate ion. Okay, so percentages are going to be conversion factors. So I'll write that down. So what this means is 0.014 or out of 100 kilograms, so we'll just say kilograms, out of 100 kilograms, and I'm saying kilograms because they give us kilograms of ocean. So out of 100 kilograms of ocean, that's going to be equal to 0.014 kilograms of your HCO3 minus, your hydrogen carbonate ion. Okay, so that's a conversion factor. We can use that later. Okay, there's no other information they give us. The question, though, is here. Remember what I said about the question. It's where we're going to find the end of our problem. So the beginning of the question is the end of the problem. So the beginning of the question is, how many pounds of hydrogen carbonate? There we go. That's what we want. So we're going to end with pounds of HCO minus, HCO3 minus. And then where do we begin? Well, remember what I said, that the beginning is going to be some information, some amount of something that they give you that's not related to really anything that you can notice. So they give us the mass of the ocean, and that's it. The mass of the ocean here is not related to anything, so it's just the mass of the ocean. So that's what we're going to begin with. So they're giving us 1.8 times 10 to the 21 kilograms of ocean, and they want us to convert to pounds of the HCO3 minus the hydrogen carbonate ion. So all we need to do is start with this amount and use conversion factors to convert to pounds. So let's go ahead and get started. So we're going to start with 1.8 times 10 to the 21 kilograms ocean. And then I'm going to use conversion factors to convert until I get pounds on top. Once I get pounds on top, I'm done. So kilograms. So I need to go from kilograms of ocean to pounds. I need to get to this amount. I need to get to hydrogen carbonate ion. Well, I have a relationship here between kilograms of ocean and kilograms of hydrogen carbonate ions. So I'm going to use that first. So 100 kilograms of ocean goes on the bottom because I have kilograms of ocean on top. I want to cancel that out. So I'm going to put 100 kilograms of ocean on the bottom. And then on top, 0.014 kilograms of the hydrogen carbonate ion on top. So kilograms of ocean cancel out. Now I have kilograms of HCO3. Now I need to convert kilograms to pounds. So let's go ahead and do that. So I need to use conversion factors that are going to get me to pounds. Well, I know that 400 and I think it's 53.6 grams is equal to 1 pound. So if I convert kilograms to grams, I can use that to convert to pounds. So let's go ahead and do that. So kilograms, I need to convert kilograms to grams. I know that 1 kilogram is equal to 1,000 grams. So you know that relationship, or you should know that relationship. So 1 kilogram is equal to 1,000 grams. Why do I know that? Because I know kilo is 1,000. A kilogram is 1,000 grams. So I can use that as a conversion factor. You should know your metric units, metric conversion factors. Okay, so 1 kilogram HCO3 minus goes on the bottom to cancel out kilograms on top. And then 1,000 grams of HCO3 minus goes on top. So kilograms cancels out. Now I have grams. Now I can use the relationship between grams and pounds. And that's going to be, let me write it up here. So 453.6 grams is equal to 1 pound. So I have grams here. So 453.6 grams HCO3 minus on the bottom. And 1 pound, 1 pound of HCO3 minus on top. So grams cancels out. Now I have pounds. I'm done because remember the question is asking how many pounds of HCO3 minus. So now I have everything set up. So all I need to do is multiply by everything on the top, divide by everything on the bottom, and I get my answer. And when I do that, I get 5.6 times 10 to the 17 So 5.6 times 10 to the 17 pounds HCO3 minus. So you can see here that I have two sig figs. The reason is because you notice that the measurements they gave us, this one has two sig figs, this one has two sig figs. When we're multiplying and dividing, remember that our answer, the rule is that our answer should have the same number of sig figs as the least number of sig figs in our measurements or inexact values. We've only got two of them, this one and this one. This is exact. This is a measurement, but we've got 4 sig figs here, so that's more sig figs. So the least number is 2, so that means our answer should have 2 sig figs. So 5.6 times 10 to the 17 pounds is our final answer. Okay, what about this one? Again, we're going to read the problem, we're going to pull out the information, we're going to look for conversion factors, and then figure out where we're going to start and where we're going to end in the problem. So it says if your body contains 5.2 liters of blood and 78% of your blood, there's a percentage again, by volume goes to your muscles. So 78% of the blood that's being pumped through your heart, through your body, oops. Sorry about that. So 78% of the blood that's in your body is going to your muscles. So we're going to use that as a conversion factor. So we know, therefore, that out of 100, what do they give us? Liters? We'll use liters then. Out of 100 liters of blood that is pumped through your body, through your heart, that means that 78% of it out of 100, that's 78 out of 100. So 78%, always read percents as out of 100, and that will, I think, make it easier for you to remember how to do the conversion factor. So here we're said of the blood that's being pumped through your body, that you have in your body, that's pumped through your heart, right? 78% of that blood is going to your muscles. So 78%, that's out of 100. So 78 out of 100. 78 what? 78 liters, right? Out of 100 liters of what? So out of 100 liters that is pumped through your body, through your heart, 78 of those are going to go to your muscles. So 100 liters of blood, we'll say blood to the heart. Out of 100 liters of blood that goes through your heart, 78 of those liters of blood goes to the muscles. So BH is blood to the heart, BM is blood to the muscles. We got to distinguish between what we're talking about here. Okay, so that's our conversion factor. Now, there's no other conversion factors or relationships they give us in the problem, but that doesn't mean that we aren't going to use any others, just like in this problem here. Excuse me. So now to figure out where do we begin and where do we end. So remember what I said, the end of your problem is the beginning of the question. So here's the beginning of the question. How many liters of blood goes to your muscles? So we want to know, we're trying to find liters of blood to the muscles. Well, what are we going to start with? Well, the only other thing they gave us is 5.2 liters of blood that's in your body, that's getting pumped through your heart, right? So that's not related to anything, so it's not really a conversion factor. It's the only thing we have. So that's what we're going to begin with. So 5.2 liters, and we'll say blood through the heart. I know in this problem they don't mention blood being pumped to the heart, but basically that's what's going on. Blood is being pumped to the heart. Not all of it is going to your muscles, but some of it, 78% of it is going to your muscles. So now that we have everything set up, now we just start with where we start with, and we're going to do conversion factors. We're going to multiply by conversion factors until we get to liters of blood to the muscles. Once we get there, we stop, we're done, we do our calculation, and we find our answer. Okay, so let's start with 5.2 liters. And this is going to be blood to the heart over 1. And we need to get liters of blood to the heart to blood to the muscles. Well, we know this conversion factor here, so we can use this conversion factor to help us convert from liters of blood to the heart to liters of blood to the muscles. So for every 100 liters of blood to the heart, 78 of those liters is blood to the muscles. So blood to the heart goes on the bottom. So we're going to put 100 liters. Blood to the heart on the bottom to cancel out here. And then we're going to put 78 liters blood to the muscles on top. So liters of blood to the heart cancels out. And we got liters of blood to the muscles. Looks like it's a one-step conversion because we got liters of blood to the muscles. That's all we needed. So we're done here. All we need to do is now multiply by the top, divide by the bottom, and we get our answer. And when we do that, we get 4.056. 4.056 liters of blood to the muscles. Now we got to figure out how many sig figs we're allowed to have. So we have two measurements. So we have 5.2, that's 2 sig figs. And we have 78, that's 2 sig figs. And so remember, with regard to sig figs, with regard to multiplying and dividing, your answer should have the same number of sig figs as the least number of sig figs when you're multiplying and dividing. Now, so in this case, we have 2 sig figs here, we have 2 here. Now, you probably might be wondering about the 100 here. We're not worried about the 100 because this 100 actually comes from the percentage. So this is our percentage. Percent means 78 out of 100. Out of 100 is what percent means. So this 100 is just there to change the percentage into a fraction out of 100. So this 100, although it does have 1 sig fig, this is really not, this is ignored. So we're not paying attention to that. So we have 78, 5.2, that's 2 sig figs. 2 sig figs is the answer, or the least number of sig figs. So that means we need to limit this to 2 sig figs. So the 4, the 0, we're going to cut it off. There's a 5 here. That means we need to round our 0 to a 1. So our final answer is 4.1 liters of blood to the muscles. So that, ladies and gentlemen, is the answer. And that's it for this video. I hope you enjoyed this video. If you did, if you learned something from this video, anything from this video, then please like the video, share the video, hit that like button over there somewhere. Also, make sure you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you'll be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, or if you have a problem or issue or question you need help with, please put it down below. I would love to help you with that. Thanks for joining me, and have a great day.